chemistry, that is resonance. I suggest you to write the notes simultaneously while watching this video, because this will help you immensely later. And remember students, anyone who wants to master organic chemistry must understand resonance very clearly. So, with this let us start resonance. Sometimes there are many organic molecules whose properties cannot be explained by a single Lewis structure. Sometimes it is impossible to write a single Lewis structure for a molecule. We can write more than 2 Lewis structure for a single molecule. Let us consider the case of benzene. So, the benzene can be written, the 2 Kekulé structure, these are called Kekulé structure. So, 2 Lewis structure or electronic structure can be written for benzene. This is one and this is structure 2. So, both of these structure, if you see both of these structure, according to these structures, there are 3 carbon-carbon single bond and 3 carbon-carbon double bond. So, in benzene, according to this Lewis structure, there must be 3 carbon-carbon single bond and 3 carbon-carbon triple bond. But experimentally it has been found that all the carbon-carbon bonds in benzene are equivalent. आमे भाबुतले कोन हमकु मिलिबो 3 double bond and single bond, but actually all the 6 carbon-carbon bonds in benzene are equivalent. Their distance is actually 139 picometer. That is, the bond length in benzene carbon-carbon is 139 picometer. As we know, the normal carbon-carbon single bond is 154 picometer and normal carbon-carbon double bond is 134 picometer. But the length of carbon-carbon bond in benzene is actually 139 picometer. That means it is neither completely single bond nor completely double bond. It comes within the range of the single bond and the double bond. That means all the bonds in the benzene are having partial double bond character. And as you see, none of this structure can explain the partial double bond character of carbon and carbon. Let us take another example. Here I am writing the same, that benzene, it is the structure of benzene 1 and 2, but it is the true structure of the benzene. It is the true structure of the benzene where all the 5 electrons are denoted as delocalized. देखो सबु तक एठी ना डबल बॉन्ड अछि ना सिंगल बॉन्ड अछि, देखाई छि कोन as if all the electrons are revolving in a circle or they have merged with one another, all the p orbitals. Next, let us take another example. So, for carbon dioxide, we know the structure of carbon dioxide. This is the structure of carbon dioxide. So, actually for carbon dioxide we can write 3 Lewis structure 1, 2 and 3. Mark in the structure number 1, there is carbon oxygen double bond, there is carbon oxygen double bond, whereas in structure number 5, I have denoted it as 5, there is oxygen with a positive charge over one oxygen and negative charge over another oxygen. So, there is a triple bond as well as a single bond between carbon and oxygen. In the third structure also there is a triple bond as well as single bond between carbon and oxygen. So, it has been found that carbon oxygen bonding in carbon dioxide is having a bond length 1.15 Armstrong, whereas the normal carbon oxygen double bond is having a bond length 1.22 Armstrong and a normal carbon oxygen triple bond is having a bond length 1.10 angstrom. That means the carbon oxygen bond in carbon dioxide lies between double bond and triple bond. That means you cannot tell whether the bond between carbon and oxygen in carbon dioxide is completely double bond or completely triple bond. It lies between the double bond and the triple bond. So, you have seen the example of benzene. Benzene रे देखो कौन होची ना जे कौन से Lewis structure cannot explain all the properties of the benzene completely. Similarly, in case of carbon dioxide also, all these three Lewis structure cannot explain all the properties of the carbon dioxide molecules accurately. Hence, बर्तमान concept है कौन resonance रो. तो now तम मानकर किछि ना किछि आइडिया पळे आसबनी रेजोनेंस रो. सपोज देयर इज ए स्ट्रक्चर, suppose there is a molecule X, and for X molecule I can write 1, 2, 3, 4 number of Lewis structures. X molecule ପାଇଁ चारटा structure आमे लिखि परिबा. Then what is the true structure of X? Now the true structure or the true molecular structure of X is neither 1, neither 2, nor 3, nor 4. It is a hybrid of 1, 2, 3, 4. माने पूरा 1 भलिया देखिया को हबनी कि 2 भलिया हबनी कि 3 भलिया हबनी कि 4 भलिया हबनी. से कोन करबो समस्त गुटु किछि किछिटा तार प्रॉपर्टी मिसी कि द ट्रू स्ट्रक्चर ऑफ X आसीबो. एंड दिस इज कॉल्ड रेजोनेंस हाइब्रिड. Resonance hybrid. मन रखा the true structure of the molecule which cannot be represented on a plane of paper. एटा हमें plane of paper रे लिखि परिबा नाही. Why? Because it is a 3-dimensional structure. हैला. So it cannot be represented on a plane of paper and it is called resonance hybrid. And all the rest structures which we are writing are called resonating structure or canonical structure or contributing structures. So, in case of benzene, these are the resonating structures or contributing structure. The structure 1 and the structure 2 of benzene are resonating structure or contributing structure. But this is the true structure of the benzene which is called resonance hybrid. And we cannot represent it on a plane of paper. तो बर्तमान लुईस स्ट्रक्चर डेफिनेशन ताले देखियो सॉरी रेजोनेंस डेफिनेशन देखिबा हमें. तो एठो असला कांसेप्ट कोन रेजोनेंस रो. Some molecules cannot be represented by two or cannot be represented by a single Lewis structure, and they can be represented by two or more canonical structure or Lewis structure. These structures can explain most of the properties. Remember, mark the word most of the properties, but none of them can explain all the properties. किछि किछिटा property बुझेई परिबे but सबुतक property बुझेई परिबे नहीं. The real structure of the molecule lies in between all these electronic structures, and such molecule is said to exhibit कोन resonance. जेतले तमे गोटे molecule पई गोटे Lewis structure लिखि पारनो गुडे दि तीनटा लिखियो पड़छो आ any structure cannot explain 100% all its properties, then that molecule is said to exhibit resonance. So this is the definition of resonance. The same thing, more than one Lewis structure we can write for the molecule, and then the compound is said to possess resonance. So what is the resonance? Now resonance actually involves the shifting or the movement of pi electrons. We must remember these things, pi electrons. Resonance involves the displacement or the movement or the shifting of the pi electrons. काहेकि एमती होची ना pi electron गुडा गोटे जगह न रही कि they are shifting from their places from one orbital to another. And remember that this is a intramolecular phenomenon, means resonance always happen within a single molecule, not outside a molecule. So, first of all you must understand that resonance occurs due to the movement of the pi electron or the lone pairs of electron, and second is that it is an intramolecular phenomenon, that is it is happen within the molecule. Now, the various Lewis structures which cannot explain all the properties of the molecules are called contributing structure, I have already told you, or canonical structures or resonance structures. Okay? And the original structure or the true structure of the molecule is called a resonance hybrid. Remember that the various resonating structures are separated by a double headed arrow. Suppose 1, 2, 3, 4 you can write n number of resonating structure, then you must separate them by a double headed arrow. This is the sign of resonance, double headed arrow. A resonance hybrid, remember that, exhibit exceptional stability. काहेकि देखो always nature favor stability. जदि कौनसी सिस्टम किंबा कौनसी प्रोसेस जिनसटा को स्टेबल करनी, nature will not follow that. So, nature always favor stability and resonance gives unusual stability to the molecule. And why this stability occurs? Now, this stability occurs due to the shifting of the pi electrons. Now, this stability can be measured in terms of energy, that is called resonance energy. What is resonance energy? Now, resonance energy is the difference of the internal energy of the most stable, that is resonance hybrid. It is the difference of energy of the resonance hybrid and the energy of the most stable Lewis structure. Resonance hybrid energy आउ maximum stable जो Lewis structure होची ता energy difference टा कहा जाए resonance energy. Higher the resonance energy, more is the stability. For example, in case of your benzene, the resonance energy is 36 kilocalorie per mole, whereas in case of carbon dioxide, the resonance energy is 30 kilocalorie per mole. Now, let us see what are the chief conditions of resonance. While writing the resonance or resonating structures, you must remember that resonance involves only the shifting of the electrons and not the atoms. You cannot change the position of atoms while writing the resonating structures. Position of the atoms must remain same, otherwise this will not be called resonance. For example, let us take this example. I am writing one example. Suppose now let us see this example. Is it resonating structure? These two are resonating structure or this involves resonance? No. Because why? See here the hydrogen is being shifted from this carbon to this oxygen. Hydrogen kon hochi movement hochi hydrogen, but we know that resonance do not involve the movement of atoms, it only involves the movement of electron. So this is not resonance. जदि बेले बेले कौन करे एंट्रांस रे से कौन करथवा ना चारटा मल्टीपल क्वेश्चन देथवा ता भितरे गोटे थिबो कोन ना एटम्स को शिफ्ट कर देथवो. So remember that this is not resonance, only you can shift the electrons, and this is actually your keto-enol tautomerism. This is a case of isomerism. तो एटा मन रखिथो resonance do not involve the movement of atoms. So the position of the atoms must remain fixed and it is the position of the electrons which get changed. Second condition, that the energy of all the canonical structure must be nearly same. They may not be exactly same, but the energy of the canonical structure must nearly be same. Then the third condition, they have the same number of unpaired electrons. Remember, unpaired electrons, the number of unpaired electrons in each resonating structures must remain same. Resonance occur when, this is very important, very important point. Resonance occurs only in a planar molecule. Remember that there are two criteria for resonance to happen. Now the molecule must be in a plane, means all the atoms in the molecule must remain in the same plane, and the second criteria is that there must be conjugation. Let us discuss that. So, for resonance to occur, two conditions are required. What are they? First one is the molecule must be planar, and the second one is that there should be conjugation. We will discuss in detail why the molecule must be planar for resonance to happen and what are conjugation. The molecule must be planar. देखो काहे की resonance होची? The resonance is occurring due to the shifting of the electrons from one p orbital to another. Suppose let us take this example. Suppose these are three carbon atoms, 1, 2 and 3. You know when the carbon atoms are sp2 hybridized, the pz orbital will remain perpendicular to it. So let us assume this is the pz orbital of one carbon, this is the pz orbital of second carbon, and this is the pz orbital of the third carbon. Now they are aligned in the same plane. What a plane ashanti? Suppose now it will be easier for the overlap. देखो overlap है परची कि नहीं? Overlap होची? आराम से एटा यहाँ से तो green टा red से तो overlap कर परची. Similarly, the blue can also overlap with the green one. Overlap माने कौन होची? Bond formation होची. But if I say this pz orbital, the pz orbital of carbon is not in the same plane and it remains like this or in tilted form. देखो बर्तमान ए दुटा गोटे प्लेन रे रहले, एटा समान प्लेन रे रहलानी. Can there will be overlap? एटा overlap हबो कि? देखो overlap करि परिबो कि? No, this cannot, there cannot be overlap. Hence the condition is the molecule must be planar. Molecule planar रहिले ही कौन हबो? ना there will be shifting of pi electrons. Pi electrons कौन करि परिबे? गोटे जगार आउ गोटे जगह को मूवमेंट करि परिबे जदि मॉलिक्यूल गोटे प्लेन रे रुहे सब एटम्स ऑफ द मॉलिक्यूल. द सेकंड कंडीशन इज दैट देयर शुड बी conjugation. So what is conjugation? Let us discuss one by one. Now, conjugation माने there will be pi bond, then sigma bond, then a positive charge. There are four types of system which can exhibit resonance. First one is pi followed by sigma, then positive charge. Another is pi sigma with a negative charge, then pi sigma lone pair of electron, then comes pi sigma pi. These are the four systems in which resonance can happen. So let us discuss one by one. First of all, let us take pi sigma positive type of system. Here mark double bond, single bond, positive charge. So it is satisfying pi sigma positive charge. तो एठी कौन हुए देखो, suppose this is the molecule we are considering. Double bond, single bond, positive charge. Okay. This is the structure of this molecule, that is CH2 double bond CH, single bond CH2 plus. Mark that this is the pz orbital. Suppose I number this 1, 2, 3. So see that the first carbon pz orbital overlap with the pz orbital of the second carbon atom and they form a pi bond. गोटे pi bond कले यार pz देखो first तार pz second तार pz overlap कला and they form a pi bond. Now mark that in CH2 plus this orbital is vacant. एठी जो इलेक्ट्रॉन थिला आउ जने किए से इलेक्ट्रॉन टोटली नहीं की पड़ेची. So this pz orbital is vacant in the third carbon. बुझेला ए दिटा overlap करचंती forming the pi bond and this orbital is कौन vacant. Suppose the second electron breaks, suppose the second carbon breaks the bond and takes away all the electron from the first carbon. से निजर इलेक्ट्रॉन भी नहीं गला प्लस फर्स्ट कार्बन रो इलेक्ट्रॉन भी निज सहित नहीं गला. ताले कौन हैला, नाउ द ऑर्बिटल इन द फर्स्ट कार्बन इज वैकेंट. पॉजिटिव चार्ज माने ही कौन, पॉजिटिव चार्ज माने ही होची वैकेंट हैला. एठी आ इलेक्ट्रॉन नाही, सबुतक इलेक्ट्रॉन कोठी पळे आसला सेकंड कार्बन पाखकु. Now third carbon ने देख लो, now the third carbon is also having a vacant pz orbital, vacant pz orbital. Now the second and the third p orbital can merge to form a bond. Second condition देखिया, third देखा बर्तमान कौन हला, बर्तमान देखो ये फर्स्ट कार्बन टा कौन हला वैकेंट रह गला. जितेबाला कि सेकेंड कार्बन आउ थर्ड कार्बन कौन कले बॉन्ड कले. सो नाउ द कंडीशन बिकम्स लाइक दिस. इनिशियली कौन थिला 1 आउ 2 भितर पाई बॉन्ड थिला. वर्तमान कौन हैला से बॉन्ड टा कहा भितर गला 2 आउ 3. आउ थरे हम बुझौची, इट विल बी इजियर फॉर यू टू अंडरस्टैंड. Mark these two electrons, CH2 double bond CH single bond CH plus. These two electrons, mark these two electrons, एठी जो pi electron bond टा है, these electrons belong to, one electron belong to this carbon and one electron belong to the second carbon. Now what happens, suppose there is a positive charge over the third carbon. So the third carbon is in the need of the electrons. So it will attract, this pi bond electron towards its निज आड़ को नहीं गला. Now the bond is formed between CH2 CH double bond CH2. The pi electron moves from 1 and 2 to 2 and 3. So, in total which lost the electron? Na carbon number 1 lose the electron. Carbon number 1 ta lose kala. 2 पाखरे देखो एठी भी डबल बॉन्ड थिला, 2 पाखरे एठी भी डबल बॉन्ड अछि. So, the carbon number 2 neither gain nor lose electron, but carbon number 1 loses electron. Hence, there will be positive charge over the carbon number 1, and carbon number 3 it gains the electron. Carbon number 3 टा कौन कला 1 रो इलेक्ट्रॉन टा निजे नहीं गला, सेति ता ऊपर कौन रहबो तार पॉजिटिव चार्ज टा सैटिस्फाई गला. सो CH2 डबल बॉन्ड CH CH2 CH प्लस तुमर कौन हबो सेटा बॉन्डिंग पर कौन है जीवो CH2 प्लस CH डबल बॉन्ड CH2. Now let's see this example. This is a benzyl carbocation. Mark here. There is positive charge. Here there is positive charge. Single bond. Then conjugate double bond. Pi bond. Single bond. Positive charge. So जो first system टा कही थी pi bond. Single bond. Positive charge. इटा satisfy करुची. तो एठी कौन हम रेजोनेंस ना देखो दिस तो देखो ये टाइप सिस्टम pi sigma positive charge, so it is satisfying our first conjugation type. So this carbon is having deficiency in electron, so it will attract this pi electron towards itself. ताले कौन हैला देखो now the pi bond moves from, remember that while you are learning resonance, try to mark the carbons 1, 2, 3 like this, so that it will be easier for you to understand. So this is carbon number 1, 2 and 3. So the bond moves from 1 to 2 to 2 to 3. So now, so the positive charge over the carbon will be now gone, because now it has got the electrons with itself, but the electrons move from where? From position number 1 or from the carbon number 1. So carbon number 1 will develop, so carbon number 1 will develop a positive charge, and this is one again, see there is positive charge, ये कंडीशन अच्छी बाकी कौन सी इलेक्ट्रॉन को गुंचानी एट ए टाइम मन रखता 1 2 3 1 2 3 ए टाइप रो मूवमेंट हो आ कौन सी जगह रे तुम्हें किछि भी लागिवनी केवल तीनटा पोजीशन को एट ए टाइम तुम्हें कौन करबा अटेंशन दो 1 2 3. नाउ लेट अस सी दिस कंडीशन, let us see double bond, single bond, positive charge, so it can also show resonance. Now let us see this double bond moves over here. ताले बर्तमान नेक्स्ट पॉजिटिव चार्ज टा कोठी क्रिएट हबो डबल बॉन्ड टा कहा पाखरु गला ए कार्बन पाखरु पळेला ए कार्बन पाखरु पळेला. सो द नेक्स्ट पॉजिटिव चार्ज विल बी क्रिएटेड here, that is बर्तमान कंडीशन देखो ये टाइप रसला पुनी अगेन सी देयर इज पॉजिटिव चार्ज सिंगल बॉन्ड डबल बॉन्ड, सो इट कैन आल्सो शो conjugation. So the pi electrons moves here and you will have कौन आसला डबल बॉन्ड कहा पाखरु गला मार्क करछ एई कार्बन पाखरु गला सो इट विल डेवलप ए पॉजिटिव चार्ज and finally the same structure you will get the same structure. So this is resonance and this is the way to write the resonating structure. बुझेला एटा तुमरो बेंजाइल कार्बोकैटायन रे पूरा रेजोनेंस देखाई छी ताल देखो नाउ you see the positive charge is being created over here कोठी कोठी होची ऑर्थो पोजिशन रे होची एंड दीटा को ऑर्थो पोजिशन रे होची टू ऑर्थो पोजिशन एंड एट द पारा पोजिशन हेंस वी आर राइटिंग देखो एठी जो हैला एटा कोन लिखा हैला ना here I can write delta plus delta plus delta plus the positive charge is being created over two ortho position and a para position and all of them involves double bond सेथिमे जो डॉट 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 टा दिया हिची कोन टोटल टा कवर करची because all the carbon in this structure are developing partial double bond character. Now let's move to the second carbon. Second condition, this is allyl anion. So this is the second condition, that is pi sigma negative charge. Here there is pi bond, here there is pi bond and there is negative charge. So what happens, remember that negative charge means it has excess electron. It will share electron, it can never take back the electron, it will share electron. तुम पाखरे excess अच्छी गोटे जिनस तुम कौन करियो सबले दबो ना कि सही जिनसटा नबो. So this carbon is having excess electron over it, so it will share with the next carbon. So let us see, suppose this is CH2 minus single bond CH double bond CH2. This is the condition. Now this carbon is having excess electron, so it will share the electron with the carbon number 2. Let us 1, 2, 3. Mark करो जदि एठी bond गोटे तैयारी हैला, it will also involve the breakage of the bond between 2 and 3 because carbon always have 4 valency. Valency तार केतरा बा 4टा. जदि एठी गोटे bond तैयारी करूचो माने आ गोटे bond टे निश्चिंत भांगिबो, otherwise its valency will be 5 which is not possible. Hence its resonating structure will be CH2, excess electron thila share kala, so it becomes neutral, CH2 double bond CH. Now this third carbon is getting the electron of this pi bond entirely, nije sabutaka nahi jauchi, so the third carbon will develop a negative charge. So this is the resonating structure for double bond sigma negative charge. This is your benzyl anion. This is your benzyl anion. Mark that here there is negative charge over carbon and single bond then double bond. Okay, negative charge, single bond, double bond. That means it can show resonance. तो देखो ये कौन करिवो, यहाँ पर excess negative charge अछि माने it will share and this pi bond must break. कोठी ब्रेक करिवो ना साइड कार्बन को ब्रेक करिवो, बुझियला. सेमती वर्तमान नेगेटिव देखो पुणी कोन हला माइनस सिग्मा बॉन्ड double bond. So it can also show resonance. It have move kala. Now the excess negative charge is shared between two carbon, and this pi bond moves over to the next carbon. Now there is also negative charge, sigma double bond, pi bond. So this negative charge is shared between two carbon atoms, while this pi bond breaks over to the next carbon. So here you see the negative charge is being created at the two ortho and one para position. Now the third kind of system is pi bond, sigma and lone pair. We know that whenever so we know that whenever the nitrogen is there, slide. So we know that whenever there is the nitrogen, remember that whenever the nitrogen forms 3 bonds, it has a lone pair over it. So this lone pair, now we have lone pair, sigma bond, double bond. So similar to that of pi bond, sigma bond, negative charge, jemti thila exactly semti hochi pi bond, sigma bond, lone pair. So with the help of this we can explain the resonance. Now the lone pair over nitrogen, se kon karibo, it share with the adjacent carbon. Jodi ase to share hela, then the next bond must break. Eta kon hala? Bhangila. So it becomes CH2 minus, now CH double bond NH2 plus. Nitrogen shares its electron with this second carbon, hence the positive charge will develop over nitrogen because it is sharing its own electron, nijo electron hi share kala, sethipai kon habo, there will be positive charge over nitrogen and negative charge over this carbon. Let us see the resonating structure of phenol. Mark here that this oxygen has lone pair of electron over it. So amara condition aila kono, lone pair, sigma bond, double bond, lone pair, sigma bond, double bond. So lone pair देखो share है तो double bond टा कौन होगा भांगिबो कोडी भांगिबो ना पाखो कार्बन ऊपर को सेमती देखो. Now negative charge sigma bond double bond, it can also show resonance. So it has la negative charge टा सब वाले share है between the two carbon atoms, and this pi bond breaks over to the side carbon atom. बर्तन एठी पुणी अगेन हैला कोन नेगेटिव चार्ज. सो नेगेटिव चार्ज अगेन गेट शेयर बिटवीन, मन रखता एक्सेस चार्ज अच्छी माने एक्सेस नेगेटिव चार्ज अच्छी माने इट विल बी शेयर्ड बिटवीन टू कार्बन एटम. सेटमें देखो मूवमेंटा कोन होची, मूवमेंटा केम देखा होची ना, मूवमेंटा देखौची मूवमेंटा देखौची कोन नेगेटिव चार्ज टा देखो केमिति मूवमेंट करची ना बिटवीन द टू कार्बन एटम्स. जितेबाला कि डबल बॉन्ड टाक मूव कर गोटे एटम उपरकू है, mark करो negative charge is always moving between two carbon atoms while the pi bond is moving over to an atom. So mark that in resonance in phenol you are getting negative charge over two ortho positions and one para position. So remember that OH group टा कौन करची OH group टा सब बोले इलेक्ट्रॉन दौची कहा को सिस्टम टा आमे देखियो बर्तमान काम कौन एटा केतोल सेंती हेलानी स्लाइड सो काम करनी बैक करके आउ थरे स्टार्ट करलिनी किंतु से स्लाइड सो ही काम करनी So in case of phenol we found that due to the donation of electron by the OH group to the ring actually developing negative charge over two ortho and one para position. Now the last type of is pi sigma pi. एटा सबटा सहज टाइप कौन थिबो देखो एठी कौन अछि ना अछि एठी pi bond sigma bond again pi bond. This is called conjugation. So pi bond can move here and this pi bond can move to another carbon. Remember that jette bale negative charge अछि सेटा दीटा कार्बन भितर को मूव करिवो आ जते बले pi bond टा अछि pi bond टा भांगियो pi bond टा सब बले गोटे कार्बन ऊपर को जिवो हला एई तक बेसिक जिंस मन रखथिबो. So resonating structures are interconvertible by one or more series of short electron shift. गोटे resonating structure आ गोटे resonating structure को तुमे केवल इलेक्ट्रॉन को शिफ्ट करके ही तुमे पहुंची पारिबो. All remember that all resonating structure do not contribute equally towards the actual structure or towards the resonance hybrid. तुम घरे suppose 3-4 जन मेंबर अच्छा समस्त इनकम करछो किंतु मैक्सिमम कंट्रीब्यूशन किए करे ना जहार इनकम हाईएस्ट. Similarly the more is the stability of the resonating structure or canonical structure more is its contribution towards resonance hybrid. जे जते अधिक स्टेबल हेतो से सेते अधिक कोन करिवो कंट्रीब्यूशन करिवो. Now the structures mark here the two structures of benzene structure number 1 and structure number 2 these are almost identical. जदि दी जन पूरा पाखापाखी अछंती समान अछंती obviously they will contribute equally. So two identical structure will contribute equally towards the resonance hybrid. Now structure, remember that structure with greater, this is very important, structure with greater number of covalent bonds contribute more towards the resonance hybrid. Why? Because structures with greater number of covalent bond is actually more stable. So if we see structure number 1, 2 and 3, mark in structure number 1, the number of covalent bonds are more in comparison to structure number 2 and structure number 3. Hence, which will be more stable? Structure number 1, and structure number 1 will be or will contribute more towards the resonance hybrid. ता अर्थ होची मॉलिक्यूल टा कहा भलिया बेसी दिसिबो किमा कहा भलिया बेसी बिहेव करिवो ना स्ट्रक्चर नंबर 1 भलिया इट विल बिहेव मोर. Next, the structure with charge separation. This is also very important. Remember, the structures with charge separation are really not stable and hence they contribute very less towards the resonance hybrid. चार्ज सेपरेशन माने कौन पॉजिटिव चार्ज थी नेगेटिव चार्ज थी से माने पाखापाखी थे गोटे मॉलिक्यूल भितर दैट इज कॉल्ड चार्ज सेपरेशन फॉर एग्जांपल लेट अस सी दिस कार्बोक्सिलिक एसिड R C double bond O O देखो here lone pair single bond lone pair single bond double bond so it can see conjugation देखो lone pair टा ठीक आसला एटा मूवमेंट कला या ऊपर को पाई बॉन्ड टा तो हेला कौन देखो now this oxygen is developing a positive charge and this oxygen is developing a negative charge both positive and negative charge are there in a single molecule and they are very कौन क्लोजली स्पेस्ड से एटा स्टेबल कि तुम जान पॉजिटिव और नेगेटिव चार्ज सब बेले कौन मिसिया चेष्टा करती सो इट इज नॉट एट ऑल स्टेबल दिस इज कॉल्ड चार्ज सेपरेशन दैट इज द प्रेजेंस ऑफ पॉजिटिव एंड नेगेटिव चार्ज इन ए सिंगल मॉलिक्यूल इज कॉल्ड चार्ज सेपरेशन so charge separation always leads to the instability of the molecule. Now resonating structure where the positive charge is over less electronegative atom and negative charge is present over a more electronegative atom that is more stable. सब बेले मन रखता नेचर फेवर करे जार जहाँ एक्चुअल नेचर अच्छी ताको सही जिनसटा दि जाऊ फॉर एग्जांपल ऑक्सीजन ऑक्सीजन सब ऑक्सीजन इज एन इलेक्ट्रोनेगेटिव एटम तार सब टेंडेंसी थाए जो मो पाखे अधिक इलेक्ट्रॉन था so the resonating structure in which negative charge will be there over oxygen will be more stable than the resonating structure where the positive charge will be there over the oxygen atom. Let us see this example. Now it is C आछी कोन एट देखो ए टाइप रो भांगी R C double bond O ताले oxygen is taking away the electron hence oxygen is developing the negative charge. So this is much stable than this structure where suppose I am breaking the bond like this means the carbon is taking away the electron then you will get this structure. Okay. So here carbon is developing a negative charge and oxygen is positive charge. This structure is actually very unstable and hence it is practically negligible. You can neglect this one for resonance. So the resonance रे किसी contribution न थाए. So what is the resonance effect or the mesomeric effect? It is the flow of electrons from one part of the conjugated system to other creating centers of low and high electron density due to the phenomenon of resonance called resonance effect. So what is resonance effect? Now due to the resonance there is shifting of electron in a molecule. As a result positive center and negative center are created in the molecule. In the same molecule there will be electron density, at a position you will get more electron density and at a position you will get less electron density and this is called resonance effect or mesomeric effect. So there are two types of resonating effect. This is called plus R effect and minus R effect. Shortcut re मन रखो groups which donate electrons to the conjugated system they show plus R. जे तुमको दब किसी जिनस तमें ताको निश्चिंत पसंद करिवो so that is positive attitude. A type रे मन रखो. So group which donate electrons to the conjugated system or the pi system or the aromatic system they show plus R effect or plus M effect. Positive resonance effect दिखाती कि mesomeric effect दिखाती. What are these groups? These groups are your OH, OR, SH, SR. Mark that here. So the short trick is remember if a group which is attached to a conjugated system is having a lone pair, the atom which is directly attached to the conjugated system is having a lone pair over it, then remember that it will show plus R effect. Eta OH ho किंबा NH2 हो देखो they also समस्त ऊपर कौन अच्छी lone pair अच्छी so they will give to the system. So, they will show positive M effect. जो atom टा directly देखो एठी directly लगी कौन chlorine, it is attached to the carbon carbon double bond, so it will show a plus M effect or plus R effect. So good. Similarly, the groups which will have which withdraw electrons from the system, जोटा system रू नहीं जीवो, they show minus R effect. For example, C double bond O, CHO, COR. एटा मन रखा टेक्निक मन रखा. The atom which is directly attached to the conjugated system, मन रखा. The atom which is directly attached to the conjugated system, if it is having a multiple bond with another atom, then that group will withdraw electron from the system. जो atom टा directly system को लागिची, double bond को लागिची, किंबा aromatic system को लागिची, that is having a double or triple bond with another heteroatom, then that type of system will withdraw electron from the ring. For एटा गोटे example देखो, किंबा एटा गोटे example देखो, सबू example रे देखो same type रे C double bond O H marker. The atom which is directly attached to the ring is having double bond with another electronegative atom, so it will always remove or withdraw electron from the ring. Second, your nitro group N double bond O minus, देखो एटा कौन अछि, the atom which is directly attached to the ring is having multiple bond with another electronegative atom, so it will also withdraw the electron from the ring. So remember that resonance effect are of two types, that is plus R effect or minus R effect. जो group गुड़ा electron देबे system को, they show plus R effect, and those groups which withdraw electrons from the ring, they show minus R effect or So what are the effects of resonance? Now resonance effects can explain the acidity and the basicity of organic compounds. Acidity and basicity amar organic compounds ro resonance बुझेई परिबो. For example, let us see the acidity of organic acid. हला acidity माने कौन? The more easier one can donate H plus is more will be the acidity. जेते सहजरे जने देई परिबो सेते द्वारा कोन हो acidity अधिक हो. For example, acetic acid and your alcohol, हला which will be more acidic? Now acetic acid will be more acidic than alcohol. And tomorrow class we will discuss these things, how resonance help us to understand the acidity and the basicity of organic compound. So with this I am finishing today's class. Have a good day.